Hello class, this is review for semester exam part 1. Now what I want to show you from this definitely has the formula chart involved, okay? So this basically is for the CFA number 4, but we may refer back to it just in case we have some review problems that call for it, okay? So we may use the Pythagorean theorem, the slope-intercept form, or the point-slope form, but something on this formula chart we're going to need for the review for the semester exam. So let's get right to it. Okay, make sure your name is up here at the top. Don't forget to put your name. And let's get started. So here we go. Number 1, true or false? And let's explain. If x squared is equal to 49, then x is equal to 7. Well, this is actually a false statement. And the reason why it is a false statement is because x, if it is squared, and we use 7 to square it, then yes, for sure this would be 49. But if we also square x and we use a negative 7, we also get a 49. So what we're not taking into account is the fact that we can have a plus or a minus 7 involved. So no, this is a false statement. Okay, and there's our explanation. We can have a plus or a minus 7 involved. Number 2, write the biconditional statement. If two angles are complementary, then their sum is 90 degrees. If two angles' sum is 90 degrees, then the two angles are complementary. In order for us to be able to write these two sentences as a combined sentence, as a combined biconditional statement, we need to use something in the middle of the sentence, and it is if and only if. And this is something that I taught you a long time ago, and I'm hoping you remember. If and only if has to be in the middle of the sentence. Okay? So let's erase it and let's put it in the sentence. Okay? So two angles are complementary if and only if their sum is 90 degrees. Okay? Write an equation of the line parallel to y is equal to x minus 3 with the point 0, 2 on it. Okay, so let's look originally to this equation, x minus 3. What is the slope? The slope is equal to 1. And in parallel lines, okay, parallel lines, this is the symbol for parallel, you need to have the same slope. So it has to be m equal to 1. So we're going to put this m in the point slope formula right there. Now, where does this y1 and x1 come into play? Well, this point right here that they give us, 0, 2, is in the format of x comma y. So x is 0 and y is equal to 2. So you're going to put these values here and here. So we have slope is equal to 1 and y1 is equal to 2 and x1 is equal to 0. So let's put it into the point slope form and then simplify it. So it's going to be y minus 2, which is equal to 1 parentheses x minus 0. And x minus 0, or any number minus 0, is going to be that number. So that just simply becomes x. We're going to multiply it by the slope of 1, and we still have y minus 2 on the other side. Now we're going to multiply 1 times x, and that's just x. And so we have y minus 2 is equal to x. Add 2 to both sides. And you're left with y is equal to x plus 2. And this is parallel to the original one, which is x minus 3. And it goes through the point 0, 2. Okay, next problem. What points are collinear? Now, what does collinear mean? Well, collinear means it is on the same line. Okay, so this line is the only line that's showing. We have GH that's they're basically out in space, and this line going in both the left and the right directions are these points A, F, and B. These points are the only ones on a line. So, what are the points that are collinear? A, F, and B. And that's what you would box in. Okay? Problem number 5. What is the measure of the unknown angle? Well, what the makers of this review did was they put a question mark there, and we normally see a variable or something like that to be able to indicate to us that there's something missing or something we're looking for. So let's replace that question mark with an X. And that's usually our technique to be able to answer questions in mathematics, especially in algebra. So we know from a theorem that we had a while back that these two are supplementary. This angle and this angle, right? Both of those equal to 180. Well, that angle is not shown, or they don't tell us what it is, but we do know that they're supplementary. What that means is that the 23 is basically the addition of x plus 69. Because whatever this angle is, this one right here, since it's not going to be counted, the other two have to add up to whatever's left from the 123. Okay? So we have x plus 69, which is going to equal to 123. That's basically what it breaks down to. These two angles have to equal to 123, because this missing angle, this one, will add to 123 and become 180, since the angles inside a triangle all sum to 180 degrees. So now what we're going to do is we're going to subtract 69 to both sides, and we'll find out what that answer is right now. And we're going to do some borrowing here. So it's 1, that's 4, and the other one is 5, so it is 54 degrees. Okay, next problem. What is the measure of angle ABD? Now these two angles are supplementary, that one and that one, because it's part of a straight angle. So they add up to 180 degrees. So what you can do is you set them both, 4x plus 6 plus 11x minus 6 will equal to 180 degrees. Okay, let's do some combining like terms. There's 4x and 11x, that becomes 15x. And the 6's actually simplify each other. And so what you're left with is 180. So we divide by 15 on both sides. So x is equal to 12. But that does not give us the angle of ABD. We have to use the x to put it back into the formula and figure out what ABD is going to be. So this is the part that we need to put the variable, what it's equal to, for x. So it's going to be 4x plus 6 is going to be equal to angle ABD. And so 4 times 12 plus 6 will equal to angle ABD. And so this becomes 48 plus 6, which is equal to angle ABD. And this becomes 54 degrees for angle ABD. I don't like that box, so let's do it again. ABD. All right, number 7. Find the hypotenuse of the right angle, round to the nearest tenths place. Okay, this is a right triangle. And right triangles from our formula chart can use the Pythagorean theorem, which says a squared plus b squared is equal to c squared. So we come back to the problem, and we can say this is c, because these other two are the smaller sides. Now, how do you know where the hypotenuse is going to be? Well, the 90 degrees always faces the hypotenuse. So that's why we know where c is at. So we're going to have a squared plus b squared is equal to c squared. And 7 squared plus 2 squared is equal to c squared. So this is 49 plus 4 is equal to c squared. This becomes 53 is equal to c squared. So in order for us to find out what c is, we're going to have to take the square root of both sides. So c becomes, and 53 square rooted is equal to 7.28. So here we go. C is equal to 7.28 units. Don't forget the units. Okay, let's go to the next problem. What is the value of x? Now, the type of angles that you see here are vertical angles, and vertical angles are congruent to each other. So we're going to have 4x plus 8 is equal to 6x. And we're trying to find the value of x. So we basically just have to use our algebra skills to solve for the variable x. So we're going to subtract 4x to both sides. And that simplifies, so 8 is equal to 2x. And so we divide by 2 to both, and we find out that x is equal to 4. And since x is neither an angle or a distance, we can just leave it as the variable x is equal to 4. Number 9, what is the value of x? Okay, this is called segment addition. UV plus VW is equal to the total distance of UW. Now remember, all of these are segments, so we got to put those symbols up there to represent that. All right, so let's put the values of each. UV is 5 plus VW, which is x plus 2, and UW is going to be equal to 2x. All right, so let's do some simplifying. 5 plus 2 is 7, plus x is equal to 2x. And we subtract by x to both sides. And we get the answer, x is equal to 7. Okay, next problem. The lines are parallel. What is the value of x? The one thing that this problem does not have, now you have to understand I did not create this review, but we are going to use it to the best of our abilities to be able to answer these questions. What we need for this problem is to know that these two lines are parallel. So I'm going to give you that information. I'm going to say, yes, these two lines are parallel. And now we can say some stuff about them. Okay? These symbols that I'm drawing on here indicate that the two lines are parallel. And if that's the case, then the alternate exterior angles are congruent to each other. Simply by knowing that they're parallel, we can say that they are congruent to each other. So 4x minus 20 is equal to x plus 10. Now we can do some solving. We're going to subtract x to both sides, and that becomes 3x minus 20 is equal to 10. And the next thing we do is we add 20 to both sides. So 3x is equal to 30. And you can already foresee what x is going to be equal to. The answer is going to be 10. It was a pretty simple algebra problem, but one that you need to know how to do. Now, what's the most important thing in this particular problem is to know that the two lines are parallel so that the alternate exterior angles are congruent to each other. Number 11, What postulate signal or justifies the two triangles congruent to each other? All right, so we have this angle, we also have this angle, and we have this side. This angle connects to this angle, and this angle connects to this side. Okay, let's see if we have that same setup in the other triangle. Okay, so we have A, which goes to this A, which is the angle, which goes to this side. Is it in the same format? Yes, absolutely. It is angle, angle, side. And that is how you determine that these triangle number 1 and triangle number 2 are congruent to each other. So what postulate justifies the two triangles to be congruent? It's going to be angle, angle, side. Number 12, the lines are parallel. Okay, now it's telling us that the lines are parallel. Now we can figure out about these two particular two particular angles. We have this one here, which is on the inside, so it's below the parallel line and to the right of the transversal. Same thing with the other one. It's this angle right here is below the parallel line and to the right of the transversal. These are called corresponding angles. Corresponding angles. And corresponding angles are congruent to each other. So we can say that 23x minus 5 is equal to 21x plus 5. Okay, so let's do some solving here. So we're going to subtract 21x to both sides. And that leaves us with 2x minus 5 is equal to 5. And now we're going to add 5 to both sides. And we definitely have to move the answers over here. We'll move it over here, so it's 2x is equal to 10, because 5 plus 5 is 10. Divide by 2, and so x is equal to 5. Again, this is not an angle. The 5 is not an angle, and the 5 is not a distance. It is just the value of x, and so x is just equal to 5. You don't have to worry about the units for that one. All right, the last problem, problem number 13. What postulate justifies the two triangles congruent? Now, I know you can't see some of the problem here because of what I was doing before, so I'm going to do some erasing so you can see the problem, and it says, what postulate justifies what? What postulate justifies the two triangles congruent? So let's see if they have the same setup, the same format. Okay, we have an angle here, and then it goes to a side, and then it goes to the angle. Notice how this is the shortest distance to get to each of the letters. So it's angle, side, angle for the first one. This is triangle number 1. Triangle number 2, we have an angle, which goes to a side, which goes to an angle. Is it the same setup? Absolutely. Angle, side, angle. Double arcs. We have a single arc over here. And so what postulate are we going to use to be able to prove that triangle number 1 is congruent to triangle number 2? Angle, side, angle. And this concludes review for semester exam part 1.